Hello, good morning or good evening, wherever your day finds you. Welcome to the Amazon Web Services Partner Webinar Series. Our topic today will feature deploying your business-critical SQL Server apps on Amazon EC2. I'm your host, Sherry Sullivan. I'm here with the Partner Marketing team in Seattle. And before we get started, I'd like to just mention a couple of housekeeping items. We are recording today's webcast, and we will make it available post-event. I'd also like to remind folks that in your browser you have the opportunity to submit questions anytime during this webcast, and we'll take a few minutes at the close to respond to those questions. So please feel free to submit as the webcast moves along. I'd also like to remind folks that we do make our content available on the AWS YouTube channel as well as SlideShare. I'm pleased to be joined today by Tony Tomarchio, who is the Director of Field Engineering with Fios, who is one of our AWS technology partners, as well as our own Miles Ward, who joins us today from Tokyo, Japan, who's the Senior Solutions Architect here at AWS. We'll begin with Miles providing us with just an overview of the enterprise infrastructure on AWS, followed by Tony, who will give us some SQL insights and a demo that showcases Sandless SQL failover cluster on AWS. So with that, Miles, I'll go ahead and transition to you. Take it away, Miles Ward.
Sherry, thank you very much. Again, this is Miles Ward. I'm a solutions architect with Amazon Web Services. I'm excited to speak with everybody today. One of the core things we're hearing from the AWS customer base is a real focus and a drive to adopt technologies that are disruptive and innovative and drive real value into their businesses. And the interesting thing we've heard is that they're able to do that with AWS because of, frankly, just how costly and complex the history of on-premises physical infrastructure is. You require, like any kind of business that's built out of parts and tin and computers and wiring and cabling and data center facilities, there are really large capital expenditures. You have the risk of very low utilization of those systems. The prices for top quality devices continue to be high. And on top of the actual capital purchases, you have all of the management and administration, both of maintenance as well as the procurement process itself of acquiring all of that capital and justifying it. And given the expense and the time required to build these kinds of systems, you also have a real reluctance and structural resistance to building things that can scale to meet the demands of businesses. What we've heard from folks like Gartner is that the core IT part of even the biggest and most efficient enterprises often spends 80% or more of its time just keeping the lights on, just running the basics that power an infrastructure. So those business values, trying to figure out how to deliver better value to shareholders, more innovative products, how to come to market faster, drove AWS to build a set of services that deliver some really significant disruptive business benefits. We wanted to build a system that demanded no upfront investment. We don't want customers, and we know that there are business opportunities that are made possible by eliminating the capital expenditure component of an infrastructure design. We also want to bring the total cost of ownership way, way down for infrastructure. These computers are supposed to be a commodity now. If anything, what cloud computing does is turn them into a utility. And we want, like all utility consumers, to lower prices as often as possible. We also think that it makes sense for businesses to pay only for what you use, just like your power bill. You don't have to pay for how much compute capacity you might need. You pay for how much you're actually using. And typically you're paying by the hour for AWS services. We also knew that with the number of customers that would want to use a system like this, that you'd really have to be able to operate in a totally self-service way. Who wants to wait for the vendor to get things set up or for things to get shipped in the mail or for builds to complete? With AWS, everything is an API or a CLI or an easy web interface away from as fast as you can work through the process, easy, fast deployment. And we've also heard from customers that because of those advantages, low cost, really only paying for what you use, and being able to control what you use, you can really grow and even sometimes more importantly shrink to accommodate the actual business need for infrastructure. How different from the old way of doing it. And because you have that ability to grow and shrink, now you can capitalize on opportunities because you've lowered the risk of experimentation. You've made it easier to follow a small experiment with a big scaled infrastructure if the market demands it, and to capitalize on opportunity. So we thought that was a good idea, and the market voted. And I've seen lots of these Magic Quadrant charts. Gartner does a good job of evaluating lots of different technical spaces, but I haven't seen very many of them with that far of a gap between the market leader and the also-rans in this space. So we're hearing from a lot of customers that we've really found something that's valuable, and we're excited to continue to invest in this business and see it grow. So what are a couple of different ways that works? First thing is we've really taken a very open approach to building systems. We want to make sure that you aren't attached or locked into any specific software vendor or stack. We have SDKs in 7 different programming languages today, and we support applications from not only the open source, or free market vendors, but also the biggest commercial software vendors in the world have chosen AWS as a great platform to run their most sophisticated applications on. So we also know that those applications now are being used across businesses in every vertical in 190 countries around the world, and delivering value from the core architecture components that line a business applications and these other kinds of core modules that drive the beating heart of big business through the big high scalability web applications, social media systems, gaming infrastructure. There's also really exciting developments in big data analysis, high performance computing, computational fluid dynamics analysis. The cloud, because of its ability to deliver high performance infrastructure at a reasonable price in a way that's controllable directly by your developers, has enabled really unique solutions across each of these different verticals. And we know that it wouldn't just be folks in Silicon Valley, it would be folks in the Silicon Beach and the Silicon Wadi and the Silicon Desert that all want to be able to use this. So we started to design and deploy the same AWS infrastructure across the world. So now we have 9 distinct regions. We're available on 4 different continents at this point. We're really able to serve customer workloads in a global way without the kind of undifferentiated heavy lifting of the contract block and tackling and currency exchanges and all the other work that it takes to build a system that really works the same with the same API across the planet. And on top of that globally distributed infrastructure that has all these benefits for latency, for locality of data, for legal compliance, for the sort of geographical penetration into different customer bases, we've also built a really broad set of services. So not only do we have these foundational components like EC2, where you rent computers by the hour, or S3, where we store data at phenomenally high durability, we also have higher level aggregated services, things like Elasticsearch, where we make it so that you can easily cloud search, where you make it so that you can easily create a search index, or we'll make Elastic MapReduce, where it's easy to run and manage big Hadoop clusters on top of AWS. So one of the most important categories of those services, places where there are lots of different approaches, is running database software. So we know the biggest applications in the world depend on structured storage, and there's a myriad different ways of building databases in the cloud. So not only can you run standard off-the-shelf relational database software directly on EC2, where you have root-level access or administrator access to individual computers that you rent by the hour, which make it so that you can design and deploy exactly the way you want without any kind of constraints about your access to the control and design. We've also heard from customers that some of that stuff is complex, and so they want more managed solutions as well. So we've built a service called RDS where we manage relational databases on demand for customers. We've also done a bunch of the foundational work and delivered products around the NoSQL market space, both hosting NoSQL databases on EC2 as well as Amazon-managed NoSQL services like DynamoDB and SimpleDB. So we heard from those customers that are running databases on EC2 that they want to run big databases. At first, a lot of customers were powering web applications or social media systems or games, but now we're talking about the core databases that power the heart of big enterprise. And so you need things like solid-state disk local to the instance up to 2 terabytes on our high ones, 4x larges, or 244 gigs of memory in the CR1 8x large instances. For data warehousing style applications, we even have instances with 48 terabytes of local disk. So very powerful instances, all of which you can rent by the hour to deliver high performance for online and offline database workloads. So we've also worked really hard on our product where we host and manage databases. That's a service called RDS. And RDS has all of these functions for pre-configuring and automatically deploying and managing at high scale database servers. We have functions for MySQL, for Oracle, and we heard from customers that they wanted SQL Server as well. So we've built this managed service to deliver and deploy those systems on their own. The big advantage for RDS is a bunch of, again, that undifferentiated heavy lifting, installing and patching and optimizing and managing each of those sort of basic functions. They get handled. One of the things that we've heard from customers around RDS is that there are more advanced replication topologies, high availability designs, other kinds of approaches that they want to be able to take to ensure that in the most critical business scenarios, they have all of the options that they might want available to build a highly replicated, highly available database. I wrote the SQL Server on EC2 white paper a couple of years ago, and back at that time, the state of the art for running SQL Server on AWS was used, frankly, some somewhat older technologies for replication from Microsoft. We used, log shipping and database mirroring with witnesses, as well as transactional replication as the approaches for maintaining high availability for SQL Server. These are systems that you can build today on EC2 where you control the SQL Server's deployment and management directly. But these functions aren't directly available when building on RDS. There isn't an automatic replicated model using the managed database service. And so we've definitely heard from customers that there's demand for more advanced, higher performance, more consistent access to the newest and best parts of the SQL Server story around high availability. So when we heard what Fios had to offer, we were pretty excited, not only for our customers and partners, but for the businesses that they represent at all of the different systems they'd be able to build at high availability and high performance because of the technologies that Fios has brought to market. So with that, I'd love to introduce David. Excited for them to show you how Fios works.
Excellent. Thanks, Miles. So as Miles mentions, what I'm going to do is review how you can achieve native Microsoft clustering within Amazon EC2. But before I get into too many of the specifics on how you can actually make this happen, I wanted to provide you with a brief background on Fios Technologies and who we are and what we do. So Fios Technologies formerly known as Fios Technologies, we focus specifically on high availability and data replication solutions. We've been around for well over a decade, protecting thousands and thousands of mission-critical servers and applications worldwide. And so what we're going to be talking about today is the concept of Sandless clustering. So we're going to jump into those details right now. So for years, the native Microsoft clustering feature that's built right into Windows Server has been the de facto standard for high availability, primarily in physical environments. But yet one of the challenges that people have in deploying this is that it requires shared storage, such as a fiber channel or an iSCSI type of SAN. And these types of storage arrays can be very costly, complex to set up and maintain. So, certainly as Miles mentioned, one of the advantages to moving to the cloud is you don't have to worry about those types of infrastructure details anymore. Plus, when you take a look at the way a traditional Microsoft failover cluster works, well, technically, the shared storage is a potential single point of failure. So if the storage goes down, you've lost your entire cluster. As you make the move to the cloud, generally shared storage isn't available, so you aren't able to set up a native Microsoft cluster without additional software. So this is exactly the piece of the puzzle that Fios solves. We provide real-time data replication software that is fully cluster integrated and fully aware. So on the next slide here, this is what I call a Sandless cluster. Also known as a shared nothing clustering architecture. So what we have here are two Windows servers, and our DataKeeper Cloud Edition technology is providing real-time block-level data replication to keep the nodes in sync. We support both synchronous as well as asynchronous block-level replication. Because we're doing this at the block level, the replication engine is very efficient, very low overhead, minimal impact on the systems and the performance of your application. So just like you would expect in your traditional SAN-based cluster, you've got your multiple nodes in the cluster, SQL servers running on your active node, and let's say there's a failure. So your primary server fails. As you would expect, the cluster would fail and it would bring your database back online on the standby cluster node. Now, the DataKeeper replication engine, because it's fully integrated with the Microsoft clustering, it handles all of the mirror reversal and the data replication redirection accordingly. So as the primary server fails and your SQL database moves to the other node in your cluster, it will start sending data back in the opposite direction. So you don't have to worry about manually keeping things in sync. That just happens automatically here. So by setting up a Sandless cluster like this, you get the best RTO or recovery time objective because you get very, very fast failover times as made possible through the native Windows Server failover clustering technologies. But you also get excellent RPO or recovery point objectives because with this real-time replication, you're not going to lose any data in the event that you have a failure of one of your clustered systems here. So this diagram is a simple two-node cluster configuration. That's not the only way you can set this up. You can also set up larger clusters if you want to do more robust failover topologies here and get better protection. So here's an example of a three-node cluster. We're replicating to multiple locations. So we do support multi-target replication. So here I've got my primary node 1 at the bottom left side of the screen here. It's the active system. And data is being replicated in real time both to node 2, which is at the bottom right of your screen, as well as to a third node for DR purposes here. And if the primary server fails, as you would expect, SQL is failed over to the next server in the priority list. That becomes the new source of your data replication. So sources and targets, again, are automatically reversed to match where the workload is being run within your cluster. So let's look a little bit more specifically how this is typically implemented up in EC2. So for maximum availability, you want to place your cluster nodes in different availability zones. So here I have an example where I've got a two-node cluster, instance 1 and instance 2, in different availability zones, and the data is being replicated in real time. Now, with a shared nothing cluster architecture or Sandless clustering architecture like this, the native Microsoft failover clustering technologies, it leverages a file share witness. This is basically to protect against split brains. You don't have multiple systems trying to bring the database on at the same time. So for maximum availability, you ideally want to deploy this in a 3 availability zone configuration. And if you have a failure of your primary instance for some reason, the database will fail over to the other node in the cluster, and everything stays up here for you. Now, some of the key advantages of deploying a Sandless cluster, especially up in EC2, is firstly, this is very easy to set up and maintain. So for most folks out there who have been deploying SQL servers in physical environments for a number of years, most folks have already set up a Microsoft failover cluster. So because of that, you're not having to reinvent the wheel or relearn anything. It's all based upon the standard Microsoft failover clustering technology that you know and love. Yet we allow you to simply do this now in any environment without that shared storage requirement anymore. And because it's fully integrated with the native failover clustering technologies, think of it like the set it, forget it principle. You just set up the replication, and from there you really don't have to think about it or manage it. That's all handled through the cluster. So this gives you the flexibility to enable the native Microsoft clustering in AWS, and it just makes it that much easier for you to adopt moving mission-critical applications into an EC2 environment here. So a little more specifics on the technology that makes this possible. What we're talking about here today is our DataKeeper Cloud Edition product, which we're focusing here on SQL today. However, because this technology provides real-time block-level replication, it really can be used to protect and cluster any application or service that you would normally protect within a Windows Server failover cluster. It could be SQL, SharePoint, Microsoft Dynamics, Microsoft Link, you name it, highly available file servers, and more. This is a very optimized, high-performance replication engine. We're doing this at the block level, as I mentioned before. So very low overhead. We don't have to worry about things like file permissions, locked files, open files. We sit beneath the file system and we replicate any data that gets written to the source system, gets replicated in real time to one or more targets that are part of that cluster. We do support both synchronous and asynchronous replication. So you can select the mode of replication that makes most sense based on your business's recovery time and recovery point objectives here. It's also very, very easy to use and set up. I'll show you during the upcoming demonstration, but we have a very simple-to-use MMC, Microsoft Management Console interface. It's literally a 3-step wizard to set up the data replication and get that mirror integrated into your traditional failover, your normal failover cluster here. Now, I often get asked, what type of overhead is involved with replication? Now, we've done a lot of optimizations here to make this very minimal. So the diagram up here on the slide, we're comparing 3 things. First of all is a standalone SQL instance without any replication, basically non-clustered. And with the Fios DataKeeper replication, now this is synchronous replication turned on, there is minimal overhead. We're looking at ballpark 10% or so for full data protection and full clustering. Now, another technology that a lot of other folks look at is the always-on availability group technology that's built into Windows Server, SQL 2012. And that, with the same workload, with their version of synchronous replication, it has significant overhead here. So we're talking 60-70% ballpark, depending on the workload here. So one of the key advantages, aside from the ease of use and the full cluster integration here, is that now with DataKeeper Cloud Edition, you get the best of both worlds. You get the full data protection, the full availability for your mission-critical SQL environment, but you're not sacrificing performance in order to achieve availability and data and data protection here. There are a number of additional benefits here as to going with a failover clustered instance of SQL with DataKeeper as opposed to availability groups here. First of all, because we're clustering and protecting the entire instance, it supports unlimited databases. It also protects your system databases. So things like your master, MSDB, your SQL logins, your SQL agent jobs, all of that is replicated and protected. If you go down the route of availability groups, you're going to have to maintain those types of things on your own, your SQL logins, your SQL agent jobs. You'll have to keep those in sync. So it's a higher administrative overhead here. By going with a failover cluster instance with DataKeeper, again, all of that is just handled for you. Also, it supports unlimited databases. Plus, it replicates data outside the SQL server itself. So availability groups is going to replicate certain databases. With DataKeeper, because we're doing disk level, block level replication, we will replicate data volumes on that Windows server, your D drive, your E drive, your F drive, whatever you set up to replicate. So if your application has data that lives outside of the SQL database, then this is going to protect that as well. Also, the final bullet point here talks about replication efficiency, and we mentioned that on the previous slide, that with a block-level disk replication technology, much less overhead and much better overall system performance here. So we have a number of customers who have adopted this model here. What I'm going to take you through here is a quick case study, and then we will jump into a live demonstration. So one of our customers is a software provider, and they provide software primarily aimed at retailers and distributors here. And they are launching a new application, or they launched a new application. And one of the requirements is that they wanted to move this workload up into EC2. But they were familiar for a number of years of deploying traditional physical servers with a back-end SAN type of SQL clusters. They wanted to leverage the existing skill set and expertise that they had built up over the years. But that said, during this transition, this is a mission-critical system, so they needed to maintain and ensure the availability of their SQL 2012 backend at all times. One of the motivators of them moving up to this environment is to eliminate, the capital expenditure type costs, servers, SANs, power, cooling, all of that, yet at the same time ensuring maximum availability here. And so, they look for a solution that would enable the native Microsoft failover clustering that they know and love and they've been using for a number of years, but they want to make that possible up in EC2. So that's why they turned to Fios to help make that happen. So what they came up with was a multi-availability zone cluster. Again, this diagram will look fairly familiar from what we've seen before, but they've got a two-node multi-availability zone, multi-subnet SQL 2012 cluster. And they're actually running multiple SQL instances. They have one SQL instance running on in availability zone, the first availability zone. They have a second SQL instance running on the other cluster node in a different availability zone. So there's actually replication happening in both directions, each node, if you will, as a backup for the other. Then in the third availability zone, they have their file share witness, which is the second opinion or the traffic cop, if you will, to ensure that failover happens at the appropriate times and things like that. So what they implemented is a two-node Sandless cluster up in EC2. The primary server fails. The SQL instance moves to the standby system, and data replication happens in the opposite direction. Now, during this time where one of your systems is down, DataKeeper maintains a bitmap technology that tracks the data that is being changed. So at this point in time, we know exactly what data has changed, what data hasn't. So when the failed node comes back online, data replication picks up where it left off. A partial resync is automatically handled and initiated to get that failed node back up to speed and in sync as quickly as possible here. the solution they implemented, again, was the specifics here on the solution, was a 2-node Windows Server failover cluster across multiple availability zones. They're running 2 SQL instances in an active-active config, so one SQL instance on node A, different SQL instance on node B, and a file share witness in their 3rd availability zone. And they're leveraging DataKeeper Cloud Edition as the real-time replication engine that's fully integrated into failover clustering to keep the different cluster nodes in sync. Essentially, DataKeeper Cloud Edition is making those local independent disks look like a single piece of cluster storage. Some of the key benefits that they were able to realize by implementing this is certainly a much better total cost of ownership. They didn't have to invest in new hardware. They're actually achieving a higher level of availability than before because the shared storage array is no longer that potential single point of failure. And because of this, they're able to easily and flexibly deploy new applications and services up in this environment and do so with the peace of mind that they are ensuring maximum uptime, and they're going to have high availability failover clusters set up whenever they deploy new applications and databases up into this environment here. And this was all done very quickly and easily. This whole solution was deployed in well under a day. Very easy to set up here. So we've reviewed the methods for ensuring high availability and forming failover clusters using native Microsoft clustering technology here up in Amazon EC2. We've talked about the DataKeeper Cloud Edition product, which provides a real-time block-level data replication that's fully integrated with native Microsoft clustering. We've talked about some of the different availability options and differences. If you're looking to protect SQL 2012, specifically failover clustered instances versus always-on availability groups. We've reviewed a case study, and what I'm going to jump into next is a brief live demonstration here. So I'm going to go ahead and share out my screen, and this will take just a moment or so to activate. So you should be seeing a screen that says connecting to server. It should be loading the desktop screen that we'll be sharing here during the demonstration. And I'm going to show you a real live, in this case, 2-node Windows Server failover cluster running up on EC2 that is DataKeeper Cloud Edition enabled. So 2 independent instances, no shared storage involved, and DataKeeper Cluster Edition is providing that real-time block-level data replication. So if we take a look at the screen here, I've got my failover cluster manager open. I also down at the bottom have the DataKeeper interface screen open. And what we're looking at here is a 2-node cluster. There's node A and node B. And I've got a couple of clustered resources here. First I have the SQL Server, the clustered instance itself, and that's the top resource here in this list. And then also I'm clustering Microsoft DTC. And this is an important differentiator here because a number of applications depend upon DTC if they leverage distributed transactions. So this is one reason where if your application does require and depend upon distributed transactions, that you're going to, for maximum protection, you're going to need to deploy a failover cluster instance as opposed to availability groups. Availability groups and is not compatible with distributed transactions here at this point in time. So here I've got my 2-node cluster. If I take a look at the SQL Server, this is what Microsoft would call a multi-site cluster here because the different nodes are in different availability zones and reside on different subnets here. So as failover happens, it will also update DNS to redirect to the appropriate IP. Now, one difference you'll notice, if you've ever set up a traditional failover cluster in the past, is the disk drive section. In your traditional physical SAN-based cluster world, this would be a cluster disk, also known as a physical disk resource, essentially your shared LUN on that SAN. Now, as I mentioned before, what DataKeeper Cloud Edition does is it abstracts the storage, and it makes 2 or more pieces of independent storage look like a single cluster disk. And that's what we see here. I've got this DataKeeper Volume H, which looks like a single piece of cluster storage, but yet it's an H drive on node A and an equally sized H drive on node B, and we are keeping those 2 volumes in sync in real time. Data is being replicated right now from B back to server A, because the current owner of the database, it's running on node B right now. In the available storage pool, you see the same thing. So here you can see the cluster disks. Again, the only difference here from your physical SAN-based cluster is you're going to see these data keeper volumes as opposed to your physical disk resources. And then if we take a look at the cluster summary screen, the one other difference, the second difference here, is the quorum configuration. So in a traditional SAN-based cluster, you would set this up with node and disk majority. So it would use a small 1 on that SAN as the third vote towards quorum. In this case, because there are no shared disks, we're doing a Sandless cluster configuration. We leverage one of the other built-in options in the cluster, which is node and file share majority. So in this case, there's a simple file share witness, which in this case we placed in a third availability zone for maximum protection and uptime. Simple file share that's part of the cluster, and it acts as the third vote towards cluster quorum here. So for all intents and purposes, this looks, feels, and acts like your traditional SAN-based cluster, but we're now making this all possible with software-based replication that's fully cluster integrated. So I'm going to switch, and we're going to take a look now at the data keeper interface, and then we'll go back and we'll do a failover of the clustered SQL instance from one cluster node to another, show how the data replication is automatically reversed. So the data keeper interface is a very easy-to-use MMC snap-in. And what we're looking at here is what we call the server overview report, where you can see the different systems involved. So here I can see my node A and my node B, and the different drive letters that are attached. So I've got a D drive and an H drive. And you can see the state of the mirror. They're both actively being mirrored, and you can see what their role is. So what you'll notice here actually is I have replication happening in both directions. I've got my H drive replicating from B to A, and the D drive from A to B. So I really have an active cluster. My SQL instance is on one node. The DTC is on a different node. They're each acting as a backup for one another. So you can have different drive letters replicating in different directions. That's perfectly fine. If you drill down onto a job, which is what we call a mirror here, you can see specifics. So for any given mirror, you can see the source, the target, the drive letter that's being mirrored, and then the IP endpoints as well as the mirror state. So you can see full information on what is happening with data replication. The nice thing about this technology is, you go in here and to set up replication, you create a job. It is a three-step wizard to create. You pick your source server, you pick your target server, and you pick a couple of mirror options, such as do you want synchronous or asynchronous replication. And from there, you really don't have to go back into the data keeper interface if you don't want to. It all gets driven going forward through the standard failover cluster manager interface here. So if I go back now and let's do a switchover. So I want to move my SQL instance from node B back to node A. So just like you would normally, you just right-click and say, well, let's move this to node A. And it's going to initiate a switchover. As part of this, it's also going to update the IP because we're failing over to a SQL instance running in a different subnet here. As part of this process, because of the integration with DataKeeper Cloud Edition, it's telling DataKeeper to automatically switch the direction of replication. So now instead of the H volume replicating from B to A, the mirroring is now happening from A over to B, because A is now the new current owner. So everything, that took a few seconds here, but everything is back online, and my SQL database is safely and happily living on node A out of my cluster here. If I go back into the DataKeeper interface, you'll see here that for this same mirror, it now shows that node A is the source, node B is the target. So we're just reconfirming that the replication was switched over automatically through this seamless cluster integration here. So with that, that wraps up the demonstration here. I'm going to go ahead and stop desktop sharing, and we will bring it back to the slides here. So we just want to thank everybody for their time and interest here today in learning how to deploy mission-critical SQL-based applications up in EC2. We've reviewed the DataKeeper Cloud Edition technology as well as gone through a live demonstration. So I guess at this point, Sherry, I'll turn things back over to you.
Fantastic. Thank you so much, Tony. That was a great overview and a great demo, really showcasing the Fios solution there. And Miles, thank you for an overview on AWS. Folks, if you joined us midstream, we do invite you to submit some questions, and we've got some queued up. So let's jump in. I'm going to point this back to you, Tony. The question is a domain required to implement this type of configuration or solution?
Excellent question. So with the configuration that we looked at here today with the DataKeeper Cloud Edition, it is based upon the native Microsoft failover clustering technology. One of the requirements of Windows Server Failover Cluster is it needs to live in a domain environment. So short answer is yes. If you have specific needs to do this in an environment without Active Directory, what we can do is we can take that offline and we can talk about some different options as well with you. So,
okay,
great question.
Great. Another question I'll point back to you, Tony, is does the Fios solution support SQL 2008 R2 standard?
Yeah, so the DataKeeper solution, we're really application agnostic. We're providing real-time block-level replication at the disk level. So as we saw in the demonstration here today, we're replicating, we were replicating the D drive and the H drive. But honestly, the data inside that drive could be anything. It could be any application's data that can be supported. So, really if it comes down to, can you cluster it within failover clustering? And then if so, DataKeeper can replicate that data for you.
Okay, great. Is there a maximum to the number of nodes?
So that's all controlled through failover clustering. So whatever either Windows Server 2008 or 2012 has as their maximum number of nodes, that would be your upper limit. So that's really controlled through Microsoft failover clustering, not through DataKeeper.
Okay, great. Tony, another question in your direction, and feel free to jump in, Miles. Does this technology support distributed transaction controller on Amazon EC2?
Yes, great question, and the answer is yes, and that's what we demoed here today. So I had a SQL cluster, and we were protecting both a clustered SQL instance as well as Microsoft DTC, Distributed Transaction Controller. So yes. All
right, great. Is there a type of alerts or notifications that a Fios application can kick off for certain events?
Yes, great question. The answer is yes. So all of the activities get logged into the event viewer, so all of the standard Windows logs, and then they each have certain event IDs, and you can key off various event IDs to be notified when those types of events happen. So we just integrate with the native Windows logging, and then from there you can key off IDs and get notified. Okay, great.
This is a question, I think sometimes there's confusion around availability zones from an AWS perspective and sort of what that means. But the question here is, can cluster nodes span those regions as well as availability zones on AWS? Like an example would be, West Coast, East Coast, US, different geos.
Sure thing. Yes, it's really in that case, it's just a matter of setting up the appropriate connectivity between the different locations here. So generally that would be done through, a VPN tunnel or some type of an effect between the locations.
This is Miles real quick. Another component there, Amazon Web Services has changed pricing recently associated with the data transfer cost at the regional level. So normally when you would build a system that spanned multiple regions, you'd be paying the normal internet egress charges for outbound data replication from one region to another. Now we've reduced those prices, in some cases very significantly. So standard internet egress, for example, from U.S. East, or the East Coast of the United States for the question, starts at 12.5 cents a gigabyte. If you are moving data into another region, it's only 2 cents a gigabyte. That's a vast improvement. So these kinds of cross-regional replicated topologies not only function using the Fios technology, but they're also cost-effective.
Great point, Miles. Thanks. Another question, I'll go ahead and point this back to you, Tony, is unlimited database really unlimited? An example is, does it work with thousands of databases on a single server? Maybe you can clarify for folks what those limitations might be.
Sure. So from a data keeper perspective, again, we're doing block level replication. So whether there's one database or 1,000 databases, it's all the same to us. So really, when we say unlimited databases, it's however many databases you can run on SQL Server itself. So I don't know off the top of my head what the upper limit for number of databases in SQL itself, but for a given instance, you could protect with this configuration however many databases you would run on SQL itself. Let's say, for example, in a non-cluster or a standalone environment, the same rules apply here. With one of the reasons I guess we brought it up that way and phrased it as unlimited is with availability groups, there are limits to the number of databases that can be protected in that configuration.
Okay, thanks for clarifying. Another question here is more, it's sort of in the same genre, is that, what's the smallest size EC2 instance supported with the data keeper?
Sure. So the configuration we were looking at here today, let me pull that up. I believe it was Miles, correct me if I'm saying anything wrong here, but I believe it was M1.small, because with setting up a cluster, you would assign all of the cluster-related IPs. So the cluster IP, the IP of the clustered SQL instance, and so on, would be assigned to the instance as a secondary IP address. And micro, I believe, only supports it's either 1 or 2. Miles would probably have to correct me there. So if you have more than that, then you would have to go up to the next one up, which I believe is M1.small. But
yeah, Tony, you got that exactly right. There are other because of the CPU timing behavior for the T1 micro instance type, it can be, I think, a very useful place to practice installation or system remediation, workloads where you're training users on SQL on top of the micro instances, but there are very few cases that we've seen in production where SQL servers are running on the micro class. So we would recommend, at a minimum, the small instance type. And again, that only delivers 1.7 gigabytes of RAM to the workload, which we're seeing most production databases operate on larger instances. But there shouldn't be a reason on the Fios side where you wouldn't be able to run on any of the specific instance types.
And the demo we saw here today was the cluster nodes Node A and Node B were M1.small.
Okay, great. Follow-on question specifically around Data Keeper, and I'll point this back to you, obviously, Tony. Is the Data Keeper, is it limited or available to AWS?
No, it's not. So you can also use and deploy Data Keeper, in your own data center, on physical servers, on virtual servers. It's a very flexible technology. So it works very nicely, and we have many customers doing this up in AWS. But you could do this with 2 physical systems in your own data center and do a very similar thing. So Data Keeper works both on-premise and in the cloud, in both physical and virtual environments.
Okay, great. So we had another question which you just alluded to, is that can the solution cluster to a non-cloud server? And the answer to that is yes.
Again, anytime multi-sites and things like that are involved, it's really a matter of ensuring you've got the appropriate network connectivity or VPN tunnels and bandwidth between the sites. With a real-time replication solution, you want to make sure it's not so important how big your data set is. It's more important how rapidly the data changes. So I call it the rate of change here, because you want to ensure that you've got sufficient bandwidth so that as quickly as the data gets written on your active server, it can be replicated across the network in real time for maximum data protection. So it really comes down to rate of change versus bandwidth.
Great. Thank you. Folks, we've got time for just a couple more questions. And Tony, this question is back around, can you provide us some insights into how the licensing for DataKeeper is, how that works?
Sure, definitely. So DataKeeper is licensed on a per cluster node basis. So the demonstration we saw here today, where I had a 2-node cluster, that would be 2 licenses of the DataKeeper software. If you want to get more specifics or any quotes, things of that nature, I would just suggest you email amazon@us.fios.com, and a representative would be very happy to help you out with all of that information.
Terrific. Well, I'd like to thank you both, Tony and Miles, for a great presentation today and really providing detailed information around Sandless SQL failover clustering on AWS. And I'd like to invite folks, before you jump off our webcast today, to take a very brief survey. We do appreciate your feedback. It helps us improve our webinar series. And so with that, I'd like to thank you, Tony from Fios, our technology partner, as well as Miles, our AWS solutions architect, for a great presentation today. And thank you, attendees, for your time. We appreciate it.
Thanks.
Thank you very much.